Hi, everyone. First of all, thanks for taking the time out for this session. By a way of quick introduction, I'm Rishab. I work at Goldman Sachs, and I'm working as a product manager, for building this app called Louisa. For those who don't know what product managers do, basically, like we work very closely with users, designers, engineers in order to solve a user's problem, because that's how we create value. So let's get into it. So there's a problem. Internal networks inside large organizations are being destroyed. McKinsey recently conducted a survey on about 5,500 US workers, and they conclude on the state of their internal networks and connections, both inside an organization and outside an organization. And they concluded that people are connecting with people within the organizations less ever since the start of the pandemic. Now, this is a concern, especially for large companies, because, ever since the start of the pandemic, you've heard of the great resignation, right? Like people have been like quitting jobs because they want to figure out what they want to do with their lives. And now after the great resignation, we might have the great termination because of the economic slowdown. So people, might have to lose jobs. So clearly there's a lot of attrition happening and a lot of internal networks that are being destroyed. Now, from the perspective of organizations, right, companies leaders need to figure out how to manage this opportunity cost and financial expenses because of this level of attrition. Now, based on a survey done, if you look at the cost that a company incurs due to attrition, it's about 1.5 to 2 times of the annual salary, and this is especially a concern. So, keeping all of these things in mind, they are basically this actually even gets even more worse in big companies. So for Goldman Sachs, if I take the example, right, we have close to around 73,000 employees working in 2,700 departments across 200 different office buildings in 130 different cities. So clearly, if you're a salesperson or an investment banker and trying to close on deals, it's impossible to know who at Goldman Sachs knows Python, for example, or Java, or knows leverage finance, or knows about European bonds, and who knows who internally and externally, people's networks, right? And as a result, you have 3 problems that arise: siloed client experiences, disconnected colleagues, and missed client opportunities. On to the next one. So clearly, after what I just said, after explaining the problems, you might be wondering, okay, well, why do internal networks matter so much? You already have platforms like LinkedIn where people can connect, but internal networks really matter inside an organization for 3 key reasons. If people inside a company are well networked, they can save time by finding information. They expect to save about 20% time. Network staffs a lot more productive, because you can basically like close out on client opportunities even more, because you know who knows who and who knows what. And people have a sense of belonging. In companies where staff are well networked, they have good relationships with people in different teams, in different departments, in different divisions. They are less likely to jump ships, like moving from Goldman Sachs to Morgan Stanley, or Morgan Stanley to Goldman Sachs, and so on and so forth. Now, in a post-pandemic environment, referrals, personal connections, and perceptions of how inclusive and communal an organization is going to be will loom larger than ever in people's decisions about whether to work for a company and continue working for a company and recommend others to join. So, having talked about the problems and the power of internal networks, we actually, and the problems that exist in large organizations, we came up with an app called Louisa. And Louisa basically maps the expertise and relationships of everyone inside Goldman Sachs. So before I jump into Louisa, and I don't want to make this a product demo, because it clearly is not a product demo, and that's not what you're here for. What I want to do is basically give you a quick background on how this initiative was started. So Louisa was started as a GS Accelerate idea that was pitched by my boss, who's Rohan Doctor. He's based out of New York. And he worked, before pitching this idea in the GS Accelerate program, which Goldman Sachs started, he worked in Hong Kong as a sales structurer. So he used to work with clients. He had He covered about like 200 global different banks across, Asia, Europe, and Americas. And as part of his role, he had to traverse through different divisions, different teams in order to close out on client opportunities. So, in 2018, he apparently like closed a big trade, which was worth millions of dollars. And, he was invited by, and that caught the attention of very senior leaders inside Goldman Sachs. And they invited him to a dinner and stuff. And after he started Louisa, I asked him, hey, what made you close that deal? He was like, it was purely due to serendipity and luck. Now imagine if you could if luck could appear in your life very regularly as opposed to just relying on, just stumbling upon it by pure miracle, right? So the question is, how do you systematize serendipity? You systematize serendipity by systematizing the data that gets generated inside an organization. And as a result, you win more and you close out on deals more, right? So that was the idea. He came up with this idea called Louisa, which maps the expertise and relationships of everyone inside the organization. And at a very high level, we have these features where every employee inside GS has their rich profiles, which is automatically generated by plugging into different systems. Their expertise is also inferred. We have a powered search, which is very well powered by name entity recognition. We have a news feed where bankers and salespeople get real-time intelligence on companies and executives that they cover. We have the networks feature, very similar to LinkedIn. You can connect with people, but as I said, it's a lot more powerful because if you connect with people internally, you can do so many things like finding information. You're always open to better opportunities and stuff. And once you connect, you basically are alerted whenever an employee gets promoted or is celebrating a work anniversary or moves teams, locations, etc. And then we have the clear job openings, which relies on recommendations. So based on your skill, we match open roles. So let's move on from this and go to the problems that we actually solved. So for our product, search is very important. Like about 60% of our daily active users search on Louisa on a daily basis. And some of the problems that we found out after digging through all the data sets, we looked at about 90 to 100,000 search queries and found out that people are not just looking for, okay, first name, last name, you get the results, right? People are not just looking for that. They are basically conducting search which have different entities. Like for example, first name, a city, a location, and expertise, and they expect to get the results, right? Now, initially when we launched, right, our search was powered only through Elasticsearch. Now, some of you may already know how Elasticsearch works, and it clearly has its limitations. For example, Elasticsearch, if you want to match against keywords in basically for different types of fields, Elasticsearch will go through all the documents, look at all the tokens against all different fields, and surface the information to you. As a result, it's not very precise, and it's not customized based on the user's inputs and requirements and user's persona, basically. So what we did was we added a NER layer, name entity recognition layer, which exists on top of the Elasticsearch. So as a result, when people search for anything, the queries are a lot more precise. The results are a lot more precise, and it's basically based on the user's inputs. So for example, I am in Warsaw. If I search for something, I expect to see people maybe who have the same title as me because I'm more likely to talk to them, because we might talk at the same wavelength, who might be in Warsaw because it might just be easier for me to just walk up to their desk and talk to them, and from the same division. So just personalizing this has been made possible for us through NER. So how did we go about doing this? So we basically collected around 2,000 search queries, search strings as an input, and we basically annotated all those entities and also figured out what results do people expect to see, right? And for basically the NER technology, in order to make NER happen, we used Flare NLP to train an NER model, MLflow for tracking experiments, and Hydra for running running them with different parameters. The tokens of each of these search strings were search strings were matched against these attributes that that we made searchable, like for example, title, department, division, city, etc. And as a result, people see a lot more personalized results. The outcome of this was that we achieved an F1 score of 0.84, which is good, but there's a lot of improvements that you can make. So now you can see with NER, if I search for Piotr Warsaw Luisa, I'll see the person's name, right? Like, so I'm clearly looking for someone whose first name is Piotr, who's from Warsaw and who's from Luisa, and I get Piotr, who's from the department Warsaw and is based out of Warsaw. So who's from the department Luisa and based out of Warsaw. And similarly, we rank the results and we generate these insights. So this is one problem that we search with the help of ML technologies in Luisa inside Goldman Sachs. Moving on, the second one was connection recommendations. So we have the networking feature, which is very similar to LinkedIn. You can connect with people and just build your network, and then you can stay up to date on them. Anytime someone creates a post, anytime someone's getting promoted or moving locations, you'll see all the cards on the feed. Before we used the ML model, our recommendations were driven by basically signals that we thought were helpful, and we assigned weights on those signals. Now, the problem with that is, let me talk about the signals first. So basically, we use signals such as, okay, is the person working in a department that is as big as, let's say 50 people. So maybe I recommend those 50 people. The user is more likely to connect with those 50 people. Did he work in previous teams? So maybe we recommend people who worked in those teams before. Then we also look at Zoom metadata. So if you're talking to someone over Zoom, all those recommendations will show up in your connection recommendations. Right? So we use all these signals. Now the problem was that this is based on heuristics and signals and weightage that experts think might be right. Experts like us who assigned it, and we thought that it might be right, but clearly users have their own preferences, and our model which we had before doesn't generate those recommendations based on the user's inputs and users' preferences. So clearly the answer was using a ML model which recommends connections based on the data we have, not based on the heuristics we implement, so that the recommendations can be a lot more tailored to users' requirements. Now, how did we go about doing this? Since we did not have a data with ground truth annotation answering the question, which is whether the connection request between two people will be accepted or not, we used a model. Basically, we modeled the problem in a different way. What we did was, based on the people features and the social network that you had inside the application, we predicted whether two people are connected or not, right? And then by predicting the probabilities of pairs of not connected users, we were able to rank those connection recommendations with the hope that this will increase the connection suggestions. Users will get better recommendations, and they'll connect and not decline any connection suggestions. The inputs that were provided in this ML model were based on the same signals that we used, but it was learning based on the users' clicks, recommendation, their behavior, their persona, and etc. And the output was either 1 or 0 in the data set. 1 meaning the person connected, and 0 being the person did not accept the connection. This model was implemented, and we did an A/B testing against the previous model that we had, which was purely driven by signals. And we did this test for about 3 months, and we found out that people are more likely to connect. This basically led to like 30% increase in people accepting connections. So it worked for us. So these are the two ML models that I wanted to walk you through. Now, these are I'm sure in this forum you are probably already working as data scientists or aspire to become one. And these are pretty straightforward technologies in the ML space that you might already be familiar with. But what I wanted to show here today is basically technology is good. In the future, you're going to be implementing a lot, smart algorithms that does a lot of smart things, but it means nothing unless it's solving a user's problem, right? I would recommend that if you're working in a product-based company, please work with your product managers to really understand what users' problems are, empathize with them, and then build your algorithm and leverage the beauty of technology to solve those problems. So keep your ideas. So don't keep your ideas in the laboratory. Go out in front of the users and then improve them. Thank you. Maybe we'll do some questions and answers.
Yes, take a look. Yes, a lot of time. And take a look look at this slide platform. No questions, and maybe there are questions from the audience. I do understand it's a late hour, but please go ahead. No questions? Yes, I think it was crystal clear, so let's use the time and please scan this QR code so you can connect with Rishab and maybe pose the questions later. Again, please bravo to our speaker. Thank you, Rishab. All
Thanks
the
for your
best.
time and patience. Thank you.